All right, so let's do exercise 8 in section 2.2. So this is another one of these limit problems where you have a picture of a function, in this case r of x, and that's in red, and we have to answer some limit questions related to this. Okay, so the first one says, what's the limit as x goes to 2 of r of x? Okay, so remember, if you see the limit and the thing it's going to doesn't have any decorations like a minus or a plus next to it, then that means the overall limit as x approaches 2 from any direction. And in order for it to exist, it must approach the same number no matter which direction you come from. So here's x equals 2 right here. If we approach from the left, the red curve goes down towards negative infinity. If we approach from the right, the red curve goes down towards negative infinity as well. So since from both directions the limit agrees on negative infinity, then the overall limit exists in this negative infinity. Okay? All right. Okay, so the next part, part B, says, what's the limit as x goes to positive 5 of r of x? Okay. So this one, it's the same situation, except now it's positive infinity we're looking at. As x goes from the left, the function goes up towards positive infinity. And if you come backwards from the right, it also goes up to positive infinity. And since both sides agree, the answer is positive infinity. Okay. All right, part C. Now we're looking at the limit as x goes to negative 3 from the left. Okay. Here's x equals negative 3, and in this case we only care about coming from the left. So from the left, we see the red curve goes down towards negative infinity, and that's the only part of the curve we care about. And so we write that down as negative infinity, like that. If you have a little hard, if you have a hard time seeing where this negative 3 lines up, sometimes it's helpful to draw in like a nice little dotted line, like this. Sort of illustrate this. Looks like there's a vertical asymptote there at x equals negative 3. It's a vertical line which the red function, the red curve, is not allowed to cross. All right, let's see what part D says. So part D is looking for the limit as x approaches negative 3 from the right. Okay, so once again, here's x equals negative 3. Coming from the right is this red curve. And it looks like as we approach negative 3, it goes up towards positive infinity. That section of the curve is the only one we care about, so we just write down that answer. And then, let's see. So part E then asks us not for a limit, but asks for some equations. So part E says the equations of the vertical asymptotes. Okay. And the equations of the vertical asymptotes looks like, well, vertical asymptote is just a vertical line that the curve cannot cross. And when the curve tries to get close to that line, it shoots off towards plus or minus infinity. So this vertical line here that I drew dotted is one vertical asymptote. It looks like there's another one at 2 and at 5. So I'll draw those in dotted line. Oops. Okay. Okay. Those vertical lines, I know I didn't draw them perfectly. These vertical lines are lines that, sort of imaginary lines that this red curve is not allowed to cross. And as soon as it tries to get close to it, it is deflected down towards negative infinity or up towards positive infinity, but it can never cross it. So I tried to make sure to draw a little gap between the red lines to illustrate that like this section of the curve never connects with this section of the curve because it can't pass this dotted line. Okay, and so the equations of these are just the equations of the vertical lines. Um, x equals -3, x equals 2, and x equals 5. Those are just the equations of those lines. Okay, now the problem doesn't ask for this, but just just for the heck of it, since um, if they could have asked what is the limit as, maybe I'll just write this in. So I'll write sort of extra. What's the limit as x approaches, I'm going to say -3 without any decorations. Okay, so here we found out the limit as x approaches -3 from the left. Here we found out the limit as x approaches -3 from the right. So usually it's a common thing to ask what happens as you approach -3 from all directions. And then of course the answer would be, well, there is no limit, because if you come from the left says you go to -infinity, the right says you go to a positive infinity. Since the left and the right can't agree, then we do not get to have a total limit. So there's no overall limit. It does not exist. Okay, so it's good to just sort of think of these things when you do these problems. And then the picture, you can kind of see, you know, this side goes down, this side goes up. They're not sort of coming close to each other. These sides, at least if they're never allowed to touch, at least they're sort of getting infinitely close to each other, like I don't know, like two little worms on either side of a pane of glass. They're both trying to get close to together, whereas here they're just going far apart. Okay,